In this section, we're going to look at some more problem solving. Specifically, we're going to be given some information about volume and solve it out. So a couple of these problems actually have to do with making candles, because you can melt wax. You have a certain amount of wax, you melt it, make it into whatever shape you want using that volume. So that's what we're going to look at. You have 150 cubic centimeters of wax and you want to make a cylindrical candle. If you want the candle's height and diameter to be equal, what radius and height should it have to the nearest tenth? So we want the height and the diameter to be equal. So here we've got the radius labeled. We need the radius for the formula. Volume of a cylinder is pi r squared times h. So if the height and the diameter are the same, the diameter is 2r over the radius, which means that's what we want the height to be, 2r. So we're going to substitute 2r in place of h. So when we work this out, r squared times 2r is 2r cubed. R squared times another r is r cubed. Don't forget the pi. And that equals the volume, which is 150. Trying to solve for r, so we're going to get the r cubed by itself. We're going to divide by pi and 2. So on our calculator, we'll do 150 divided by 2 and 3.14. Or you can do 2 times 3.14, which is 6.28. And that's what you divide by. So 150 divided by 6.28 is 23.885 equals r to the third. So we need the cube root to solve this out. We need the cube root of 23.885. The easiest way to do that, in my opinion, is you take that exponent and you just do the reciprocal exponent on the other side. To get rid of a cube, you do the 1/3 power. That's the easiest way to type it in on the calculator, I think. So 23.885 to the power. Just make sure you put parentheses around your exponent of 1/3. You get 2.87988. It says rounded to the nearest tenth. It's about 2.9 centimeters. Now, if the radius is 2.9, we said that the height is supposed to be the same as the diameter. So that's going to be 2.9 times 2. So 5.8. Similar question, except this time we're going to make it into a square prism. So that means we've got a square on the bottom, straight up. So volume of a square prism is length times width times height. And since it's a square, we know that these two, length and width, are the same thing. You just call them X if you want, or S, or whatever. Whatever letter you want to use. S is pretty common. And you want the candle to be twice as tall as it is wide. So the height, you want it to be double the width, 2s. So volume here would be S times the height, which is 2s. S times 2s equals the volume, which is supposed to be 300. S times S is S to the third. So we divide by 2, you get 150. And then to get rid of that exponent of 3, we're going to do 1/3 on the other side. Make sure you put it in parentheses for your exponent. You get about 5 point, let's do the nearest tenth, so 5.3. So the side blank is going to be 5.3, the height would be 10.6. It doesn't explicitly say that, but we can write it down. Now we're going to make one that is a cone shape, conical, with 15 cubic inches of wax. The candle's height is twice the diameter. So diameter is 2 radii, but the height is supposed to be 2 diameters. So that's 2 times 2r, which would be 4r, is going to be our height. So we need volume of the cone, which is pi r squared times the height. And we just said the height is 4r, so let's replace that right there, substitute it. And that's supposed to equal the volume, which is 15. So 15 equals pi times the radius squared times 4r. So if we simplify, that's 4 times pi, and then we have r squared, and r to the first makes r to the third equals 15. So to solve for r, we need to divide by 4 pi. Four times 3.14 is 12.56. We're dividing by 12.56. 15 divided by 12.56 is 1.194. And we're trying to get rid of the exponent of a 3, so we do a 1/3. Or a cube root. and you get 1.06. I think it says the nearest tenth, so 1.1. So that's the radius is 1.1. The height we found a long time ago is supposed to be 4 times the radius. So 1.1 times 4 is 4.4. So for this one, we need, if it's going to have an octagonal base, we need the area of the base times the height, that's the volume. So if you're going to find the area of this, I would split it into a rectangle and 2 trapezoids. So if it is 3 inches all the way across, and 1.2 inches right here, we have a rectangle, but what we really need to know is what is the height here. I'm going to do it in blue. It's going to be the same on each side because this octagon, everything about it should be symmetric. So we have 3, this is 1.2, which means leftover from the 3, once you subtract the 1.2, it's 1.8, which needs to be split between these 2 heights here. So we have 0.9 and 0.9 for each of those heights. The base is 3, this side's going to be 1.2 because it's the same all the way around the octagon. So we'll get the volume of this rectangle, 3 times 1.2, it's 3.6. And then for the trapezoid, we have 2 of the same, so we're just going to find 1 and we'll multiply it by 2. The base is 3, the other base is 1.2. Remember the formula is 1/2 base 1 plus base 2 times the height. So the first base is 3, the second base is 1.2, the height is 0.9. So 3 plus 1.2 is 4.2 times 0.9 and then divided by 2 is 1.89. That's the area of one of those trapezoids. I'll say this one right here. It's the exact same congruent trapezoid down here, so that's 1.89 also. So the area of the base is 1.89 plus 3.6 plus 1.89. Which is 7.38. That's the area of that octagon. Area of the base. Volume is always area of the base times height. We just found the area of the base is 7.38 times height. It's going to equal our volume, which is supposed to be 50. And we're solving for height, so just 50 divided by 7.38. So 6.775 inches.